Hello everyone, welcome back. In this video, we're going to learn about sentiment analysis. So sentiment analysis is where we're going to have a set of documents, and rather than trying to understand the inner workings of a single document, we're going to try to classify these documents as either, say, positive or negative. And positive or negative, that could mean different things in different contexts. If it was a product review, it might mean one thing. Later on, we might talk about a spam filter, where you're trying to detect if an email is spam or not spam. So maybe you say you tested positive for being spam. In this one, we're going to focus on a corpus of movie reviews. And we're going to try to come up with a machine learning algorithm which can determine, is a movie review positive or is it negative automatically. So as usual, we're going to begin by importing NumPy as NP. And we're going to import pandas as PD. I don't think we're going to need matplotlib for this video. If we do, we will import it later. Alrighty. And since this is a natural language processing video, we are going to import the natural language toolkit. And then we are going to use nltk.download to get the movie reviews dataset. Movie reviews. And then from nltk.corpus, we are going to import movie reviews. When I run this, I'm about to get a warning on my screen because I've already downloaded it, and it says package movie reviews is already up to date. That's because I do prepare for these, and so I've already got the movie reviews on my computer. So now let's take a look at what sort of object movie reviews is. It's actually going to be a little bit of a strange type of object. But the two methods which we're going to need are going to be file IDs and raw. So let's first take a look at file IDs. Okay, so movie reviews.fileIDs is going to return us a list of all the movie reviews, or the files containing the movie reviews. And now let's look at the length of this. So let's take review list equal to movie reviews dot file IDs. And then let's look at the length of the review list. And okay, we can see that there's 2,000 movie reviews. And what I'm going to go ahead is I'm just going to print the first item in the list. Okay, we see this is what's called a negative review. It's a file address, it's the file ID, and it's in a file called neg. And what it turns out is that there's 1,000 negative reviews and 1,000 positive reviews. So if we instead look at review list 1,000, we're going to see that this is going to be in a folder called pos. Alrighty. So now let's try to actually read one of these reviews. Because movie review.list, or review list is the name of the file. So in order to actually read it, we're going to use the raw method. So we say movie reviews.raw review list 0. And this is going to give us the first review. All right, we're learning about this movie. Two teen couples go to a church party. They drink, they drive, they get into an accident. There's strange apparitions. There are disappearances. Melissa Sage Miller running away from visions about 20 minutes throughout the movie is just plain lazy. Right now I'm down on here on this part of it. No, okay, we get it. People chasing her. Okay, this does indeed seem like a darn negative review. It doesn't seem like they liked it very much. So that's how we look at a single review. Now let's say how we can look at the whole data set. And as is kind of a running theme in this course, Our solution is not going to surprise you. Our solution is going to be pandas. So we're going to make a data frame, and our first column in our data frame is going to be the names of the file IDs. And in this, we're gonna have a column named file ID, and its entries are going to be the contents of review lists. So let's look at the first 3 entries of this. Okay. So now we have a pandas data frame with 1 column. But now we actually want to also get the reviews. And we saw that we could get the review of a single column with the raw method. So in order to get this to all of the rows of the data frame, we're going to have to apply it to every row. To apply it to every row, we use .apply. So we're going to make a new column called data frame raw text. And then we're going to say df file ID. And then we are going to apply. And then we're going to apply movie reviews .raw. And now let's take a look at our new data frame. Takes a second because we're applying it to a list of 2,000 movies. 2,000 is a very big number. It's one of the biggest numbers, contrary to popular belief. And yes, I am just stalling for time because my computer is being slow. Gonna quench my thirst while we do this. Alrighty. Now we got ourselves a data frame. And what we can see is that we got a file ID, and then we got this plot of the 2 teen couples go to a church party, yada, 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 yada. So now we're going to use the tools from before to create a term document matrix. And in this context, each movie review is going to be a document. So let's go ahead and let's do the stuff that we are now pros at. So let's go with from sklearn feature extraction .text import. We are going to import our count vectorizer. Then we're going to instantiate a count vectorizer. Max document frequency, we're going to set to 0.2. Minimum document frequency, we're going to set to 30. And as usual, we're going to use stomp words equal to English with a lowercase e. Oops, I hit enter prematurely there. Okay. And now we're going to say counts is going to be equal to vec.fitTransform. And then we're going to apply this to the raw text column of the data frame. Alrighty. Counts data frame is going to be pd.dataframe. We need to turn counts to an array. We've seen this a couple of times by now. And then the columns, the names of the columns, we can use the vec.getFeatureNames method. And let's take a look at our counts df. Alrighty, so here are the first 3 documents, and here's how often these various words appear in those documents, which are the movie reviews. Not necessarily a lot of ones, a lot of zeros. Like we learned earlier, these really do tend to be sparse documents. Okay. So now we're going to put this together with our original data frame. And to do that, we do df is equal to pd.concat data frame counts df axis equals 1. These 2 arguments need to be paired together in a tuple. This is very easy to forget. If I've taught you nothing else, I think I've taught you that by example. And let's look at the first 3 rows. Okay, so now we've got file ID. Here's the plot. Here's a bunch of words. Here's how often the words appear. We got our data. But we're not quite ready to get started because we still need a target variable. And our target is going to be, was this a good movie or was this a bad movie? And so to do this, we're going to create a column called is good. Okay. And so now we need to think, how can we determine from the data whether or not a movie is good? We need to think, and we can remember that there's a file ID. And the file ID starts with either NEG or POS. So that's going to be our key. So we're going to say is good is going to be equal to df file ID. We're going to split. You have to use the .str and then the split function. We're going to split on the slash character. And then we're going to get the first one, str.get. And we're going to check whether it's positive or negative. And to give us some like real flexibility, we're going to say whether or not this is greater than or equal to p. We could say that it just is it equal to pos, but now if somebody, for example, wrote positive rather than pos, this will still work. Other than the fact that I made a typo somewhere. And I believe it's that I don't need this period right there. Okay, there we go. So now our data's ready, and we're going to do sentiment analysis. And before I take a look at sentiment analysis, let's take a step back. What is sentiment analysis? It's stuff about text, but we're trying to say, is this good? Is this bad? What type of machine learning problem is this? This is a classification process. So what this means is that the rest of this video is going to look exactly like all of the other classification videos we've done. Because once we've done the data prep, and this is a meta theme in machine learning, once you prepare the data, the same tasks appear over and over and over and over again. So with that pep talk out of the way, let's get started. Let's kick some butt. Let's use our classification tools that we are now absolute pros at. Okay, so from sklearn.model selection, import train test split. Train comma test is equal to train test split. We're going to split our data frame, and in this example, I'm going to use our test size equal to 0.4. Why not? Let's mix it up a little bit. And now we want to focus in on the appropriate columns. So from the training set, we're going to say xtrain is going to be equal to train, but we're going to want to get rid of some columns with .drop. .drop, we're going to want to get rid of the file ID. And we're also going to want to get rid of the raw text because all the useful information from the raw text is now in our bag of words. And we don't want to have the target variable, so we're going to get rid of is good. We're going to do this along axis is equal to 1. And ytrain is going to be equal to train is good. And then we do the exact same thing with the test set, but we change train to test everywhere. All right, so now we can just feed this right into a logistic regression model. So we need to import from sklearn.linear model, import logistic regression. LR is going to be equal to logistic regression. And then LR.fit. Ooh, need an equal sign there. This. Alrighty. So let's see how we do. 100%. Awesome. We're done. Stop the video. No, not really. Don't. Okay, good. So we got 100% accuracy on the training set. So now you need to ask yourself, is this too good to be true? And the answer is yes, because we don't really care about the training set. We care about how it works in unseen data. What if we're overfitting? We're probably overfitting. 100% accuracy, that should set off alarm bells. You're probably overfitting. So let's cross-validate from sklearn.model selection, import cross-val score, and then let's take the cross-val score of our logistic regression model, X train, Y train. Let's set CV equal to 5, and let's take the average. All right, we got a number that's right around 80%, a little bit closer to 81%. So it's not bad, but this is certainly not as good as 100%. So now we might want to say, well, maybe we can do better. If we tune our parameters better, maybe we won't have as much severe overfitting. And so we're going to look at the C parameter of the logistic regression model and try to use cross-validation to find the best possible value of the logistic regression model. So to do this, we are going to create a C pool, which is going to be np.linspace 0.005, 0.05, and 10. We're going to start off with our best score being equal to negative infinity. Negative infinity. Don't want positive infinity, then we would be in trouble. Then we're going to say for C in C pool, LR is going to be logistic regression with C equal to C. Score is going to be this same line right here. And then if score is better than best score, then now best score is equal to score, and best C is equal to C. And so let's do that, and let's also just report every single score. So to do that, let's say print C equals np.round C3. And then let's print cross-validation score equals score. All right, we can see this running for a bunch of different things. We got an 80, we got an 82, almost 83, 82.4, 82.3, 81.9, 82, 82.1. All right, so it looks like C best is going to be about 0.01. So let's take a look at that. Let's look at the best C. Okay, it's right at 0.01. That is good. And now let's let LR be logistic regression. C equal to the best C. And let's fit this to our training data. LR.fit X train, Y train, and then LR.score X test, Y test. All right. And so we see that we were able to get a slight improvement over just using the original model. However, we're not done yet. One of the principal goals of this analysis is try to maybe learn positive, negative word associations for different words. So to do this, let's make a data frame of our scores. So we're going to make a sentiment data frame. We're going to make this be a PD data frame. Columns by word. And those will be the columns of xtrain, xtrain.columns. Then we're going to have a coefficient column, which is going to be lr.coef underscore, and for technical reasons, we need a 0 here. Let's take a look at our sentiment df dot head. Okay, we see that these words have positive and negative coefficients. And you know what? Let's not look at the head because all the interesting words there were just the numbers. Let's look at the full thing. Okay, so we can see that 0, the word 0, has a slightly positive association. York has a negative association. Youth has a positive association, and so forth. So now let's look at the most negative words. So to do this, we do sentiment df.sort values. We're going to sort by coef, and we're going to put them in ascending order. So ascending is equal to true. And let's look at the top 10. Okay, so here are our most 10 negative words. Boring, stupid, worst, unfortunately, looks, and poor. Makes a lot of sense to me. Those do not seem like good words to have in a movie review. And now for positive words, it's going to be exactly the same code, but we're going to switch ascending to be equal to false. Especially, family, true, perfect, gives. Somewhat ironically, American appears there. This must be an American audience who's filling out the reviews, and they have strong associations with their home country. And so this all seems to make quite a bit of sense, and we can conclude that our model works pretty well. Now, of course, there's many different sorts of things we might want to do, but, you know, this is a good start, and this is really a powerful tool. One last thing, I mentioned this at the beginning, but I do want to mention it again, is positive, negative can mean different things in different contexts. Another interesting example would be something like a spam filter, where testing positive for spam would mean that this is a spam email and you want to delete it. And so it's all context dependent, but I hope you've learned a lot in this video, and I'll see you again next time.